run the exercises. Now, I will just give a short introduction about the clusters. Of course, the goal is not to make you professional and have knowledge in depth about it, but at least you will know what does it mean cluster, what does it mean nodes, cores, CPUs, GPUs, and so on. So first, we can start maybe with a very short definition for the cluster. Simply, the cluster, it's a group of computers. They are working together as one team or single computer, and they are connected through a fast local area network, which is LAN. And in this case, actually, we are improving the performance and the availability. So it will become more powerful to use this group of computers. If you look at this figure in front of you, it shows whole overview of a cluster. Maybe later we will go through every single part of it, but in general, you can see here three main parts of it, which is the login nodes, compute nodes, and part about the global storage. So what we mean with the login nodes, if you see here, we have 3 units inside. For the login nodes, where they actually all the users sharing all the resources there, and it's useful for the light jobs, and it's of course not allowed to run some heavy jobs there as it's shared resources. And in this case, the users need to submit jobs to run it on the compute nodes. These compute nodes, as we can see here, it can be CPUs or GPUs with GPUs nodes. These nodes supposed to run the complex computational jobs. Here, both of them, they are connected to global storage, which is like storage file systems there. If we speak about a node, the node usually it's a single unit or single computer. Maybe we can see this picture. I can zoom it to see what we mean with a single node. So for the node, actually, we mean that we have a single computer or unit that can have more than one CPU, which is the central processing unit. And each one of these CPUs can have more than one core. In this example, we see it in the picture. We have 2 CPUs. Each CPU has 24 cores, and they are connected to shared memory and with the network adapter. Beside connecting to the local storage, which is the fast and temporary storage. And this is only example about the number of the cores here. Of course, every cluster in each university, they have different number of cores. But let's assume that this core, it's specified to be connected to one single task or one single user to do some their jobs. Again, if we look at the figure below, it is the same as we have for the processor, but with addition to have GPU part. If you see it here, it's the green part in this node. So this is the only difference here. It's similar what we have here with these nodes with CPUs, but we have GPUs in addition to that, to these nodes. So as I mentioned, the difference between the login nodes, that it's for the light jobs, and the compute nodes, it's for the heavy jobs, and how we can apply for these compute nodes. Actually, it should be through submitting a job, what we have to do in this case, we have to try to tell the batch system that we have job, we want to handle it to the compute nodes. And this brings us actually to know what is the batch system. Basically, the batch system, it's just a queuing system, and it's taking the orders from the login node, and then it's deciding when and where to run these jobs. Yeah, and this can happen through writing a job script. This brings us also to know what we mean with the job script. The job script, it's basically only a file. You can list a number of commands there to tell your batch system or the queuing system, or in our case here with NAISS, most of the clusters, they are using Slurm. We can also call it Slurm. Tell Slurm what kind of resources that you need or what you want to do with your job. For example, here you can say, okay, I want, for example, how many nodes or how many CPUs, GPUs, and how much memory you want to allocate and for how long you want to run your job. Yes, and we have to know also the syntax of the job script depends on the queuing system that you are using. In case of using Slurm, you can call it also Slurm script. So all of that, you can, all of that, like using these scripts, actually, there is less human interaction, but you can again use Open on Demand or another special program to do graphical interaction, like GFX launcher, to deal with your scheduled jobs. Yeah, so now coming to what kind of programs that can run effectively on a computer cluster. If we look here, we have two types of programs that can run effectively on our clusters. And the first one, it's the sequential jobs or the parallel tasks. So let's start with the sequential jobs or the serial jobs, when we have actually many independent single core tasks that you can run it in a over one node or over shared memory. And here we have example. Let's say you have 500 tasks. You want to run them, but what you have as allocated 50 cores in the machine that you allocate. So in this case, 50 instances will start to run, and the remaining will wait. When the running program finish, the next 50 will start, and so on. So in this case, what you are doing actually, it look like you are running 50 computers instead of one, and that will help you to finish your task in 1/5 of the normal time. So this is for the serial jobs. Also, if you have one big problem and you could divide it or split it in several parts, you can again run them in parallel and collect the results from that. And of course, you run them in different three ways. So the first way, you can run these parallel tasks either inside a single node. In this case, we call it like thread shared memory, and this is suitable with the OpenMP. Or you can run these parallel tasks over several nodes. We call it distributed parallelism, and it's suitable to use MPI programs. The third way, you can just combine both in once. How that work? You can just imagine that you have a master. This can create that can be created to control the distributed data and the tasks, and send these instructions to one or more than one worker, and the workers will process these tasks and send back the results to the master. What the master do at the end will combine these results. Yes, so here just we have a list of examples where we can use the parallel problems. It can be used with sorting or rendering computer graphics. Also, it can be used with computer simulations, like comparing many independent scenarios like climate model. Also with the matrix multiplication. Here you can find like more details about it, these three ways that I mentioned shortly, where we have shared memory inside one node or across several nodes, or the hybrid parallelism. Now, before ending this section, we have to see what is the difference between the CPUs and GPUs. So shortly, the CPUs, which is the central processing units designed to handle a wide range of the distinct tasks sequentially, while the GPU is designed for high-end parallel computing. Yes, so one more point I have to mention here, that using the GPUs, it's not automatically or by default. So you have to adapt a little bit in your code in order to use the GPUs. This can be done through several programming frameworks like CUDA, OpenCL, OpenACC, HIP, etc. Or you can use it through like software, like Python packages. Okay, so I hope that this is giving you an idea about, in general, what is the clusters. One more thing you have to know, or maybe you will hear about supercomputers. And we have here a question, if the supercomputer, is it the same as cluster? So the short answer for that, it is not. So the cluster can be a group of supercomputers, but the supercomputer, it's usually a single computer. It has many CPUs and large volume of shared memory, which make it more powerful. Okay, so this is just short introduction for that, and maybe I should handle that to the next lecture of batch system concept with Jochen. Thank you. Any question?